Torx, developed in 1967 by Camcar Textron, is the trademark for a type of screw head characterized by a six-point star-shaped pattern. A popular generic name for the drive is star, as in star screwdriver or star bits. The official generic name, standardized by the International Organization for Standardization as ISO 10664, is hexalobular internal. This is sometimes abbreviated in databases and catalogs as 6-lobe. Torx Plus is an improved head profile. Torx screws are commonly found on automobiles, motorcycles, bicycle brake systems, hard disk drives, computer systems and consumer electronics. Initially, they were sometimes used in applications requiring tamper resistance, since the drive systems and screwdrivers were not widely available. As drivers became more common, tamper-resistant variants, as described below, were developed. Torx screws are also becoming increasingly popular in construction industries. Principles of operation. By design, Torx head screws resist cam-out better than Phillips head or slot head screws. Where Phillips heads were designed to cause the driver to cam out, to prevent over-tightening, Torx heads were designed to prevent cam-out. The development of better torque-limiting automatic screwdrivers for use in factories allowed this change. Rather than rely on the tool to slip out of the screw head when a torque level is reached, which risks damage to the driver tip, screw head, and/or workpiece, torque-limiting driver designs achieve a desired torque consistently. The manufacturer claims that this combination can increase tool bit life by 10 times or more. The Torx design allows for a higher torque to be exerted than a similarly sized conventional hex socket head without damaging the head and/or the tool. The diagram on the right depicts the interaction between the male and female components of a conventional hex drive and a Torx drive. The clearance between the components is exaggerated for clarity. The diagram does not show a true Torx profile, but illustrates the general shape and geometry. The green circle, passing through the 6 points of contact between the two components, represents the direction of the rotational force being exerted at each of those points. Because the plane of contact is not perpendicular to this circle, a radial force is also generated which tends to burst the female component and crush the male one. If this radial force component is too great for the material to withstand, it will cause the corners to be rounded off one or both components or will split the sides of the female part. The magnitude of this force is proportional to the cotangent of the angle between the green circle and the contact plane. It can be seen that for the Torx type of design, the angle is much closer to 90 degrees than in the case of the hex head, and so for a given torque the potentially damaging radial force is much lower. This property allows the head of the fastener to be smaller for the same required torque, which can be an advantage in applications where space to accommodate the head is limited. Sizing. Torx head sizes are described using the capital letter T followed by a number ranging from T1 to T100. A smaller number corresponds to a smaller point-to-point dimension of the screw head. Common sizes include T10, T15, and T25, while T5.5, T35, and T47 tend to see specialized use. Only the proper driver can drive a specific head size without risk of damaging the driver or screw. The same series of Torx drivers is used to drive SAE, metric and other thread system fasteners, reducing the number of bit sizes required. The external variants of Torx head sizes are described using the capital letter E followed by a number ranging from E4 to E44. The E numbers are different from the T numbers of the same size. For example, an E4 Torx socket fits a T20 head. Variants. A version known as security Torx, tamper-resistant Torx or pin-in Torx contains a post in the center of the head that prevents a standard Torx driver from being inserted. An external Torx version exists, where the screw head has the shape of a Torx screwdriver bit, and a Torx socket is used to drive it. The external A-OEE Torx nominal sizing does not correlate to the A-OE size. A Torx successor, Torx Plus, a registered trademark, was introduced about 1990 when the original Torx patent was expiring. The lobes are more square to allow for higher torque and minimize wear. The name is shortened to IP with sizes ranging from 1 IP to 100 IP and EP with sizes ranging from 1 EP to 42 EP, as well as smaller sizes ranging from H7 EP to H2 EP, and includes 5-lobe tamper-resistant variants. The specifications for these licenses are held by Textron. Standard Torx drivers can be used to drive Torx Plus screws, but not to full torque because of the loose fit. Torx Plus drivers will not fit into standard Torx screws. A tamper-resistant version of Torx Plus, a registered trademark, exists having 5 lobes rather than 6, plus a solid post in the center, and is used for security as the drivers are still uncommon. Though Ackerman lists no designation, TS or IPR may be seen. Competitive variants, TTAP, which is also hexalobular, is designed to minimize wobbling without the need for magnetic bits, a feature that can be important to certain industrial users. Standard Torx drivers can be used to drive TTAP screws, but TTAP drivers will not fit standard Torx screws. AW, similar type of screw head developed by the WA 1/4 TH group in Germany. Gallery. See also, screwdriver, wrench, references.